Okay, for our voltage doubling adjustable bias circuit, the way this works is pretty simple. You have your bias winding here. On the positive swing of the AC voltage, this diode conducts. On the negative swing of that AC voltage, this diode conducts. This capacitor here charges to the full value of whatever the AC voltage is here, but this one, as it's rectified, but then this will charge to twice that amount, and then it goes across this voltage divider network and then onto a 25K potentiometer to tap off the wiper, and then this takes the place of the current bias supply to the rest of the PA circuit. Part of the challenge was coming up with the layout for this 6x6 turret board. This is the smallest one I could find that would fit in the chassis. The way this is going to be configured is you got the capacitive resistive doubling network on the first couple of turrets there. You can see those capacitors are kind of big, so we're probably going to have to just put them directly through the turrets like so. But either way, this will all fit on this board nicely. Circuit looks simple, and I tried to build the turret board as closely resembling the schematic as possible. One thing I tried to do was use a common ground side to reduce noise. So that worked out pretty good. Anyway, this won't take too long to assemble. Can do it off of the chassis and then install it in the chassis. So that'll be pretty easy. Still waiting on a couple of components, but they should be here soon. For adjusting the bias, I've got a fairly precision potentiometer here, 25 kiloohms, but it has this locking collar on it so that once the bias is set, you can just crank down on this and it will keep it from moving. We'll see if this suffices. Some people use little trimmer potentiometers. I don't like to on tube amps. I just don't feel they're robust enough. This should be adequate. This will be mounted on the chassis somewhere. So the goal of this is to be able to test and adjust the bias without having to take the chassis out of the head shell and exposing all that other dangerous voltage while I tweak on it. So anyway, I don't like to drill in the chassis with components in there, but I kind of didn't have a choice because I wasn't certain how things were going to lay out. If I had to do this amp a second time, I would already pre-drill all the holes, including the test points and all that stuff. But in this case, I used a vacuum cleaner to make sure that I kept all the filings away from the components. I'll probably take it off again once or twice to do some strapping underneath if I need it. But for the most part, 12 terminals should cover all the components for the bias circuit. Okay, we're starting the PA side of the amp today. I'm using the Sierra Tone scat so I can install the test point, the bias test point mod here. It's real simple. They're just 1 ohm resistors that go from the test point to ground, and then you bring in the cathodes instead of grounding them on the socket like normally you would bring them to these test points. The theory is Ohm's law, voltage equals current at 1 ohm, so we'll have a drop across these resistors. We can stick a meter in the banana plugs and measure the current as we adjust our bias. We don't have all of our parts in for our adjustable bias yet, so we're just going to start on the tube. I always like to work from the cathode up through the tube, so we're going to start with this cathode circuit here, which is just going to be ground and test points. Then we're going to move to filaments, which are these green wires coming in here, and then on this schematic they show them red going across. But it doesn't really matter what color actually. This is the 6.3 volts AC filament, so low voltage but high current to heat up the heaters in the tube. And then we'll start bringing the control grid voltages across from the power supply turret board, and off we go. So these are 1 ohm 5 watt resistors that are tied into the cathodes and then ground, so I can get my bias readings. I had to get a little creative in getting them in here neatly, but I think it's okay. I think it'll be fine. I had to undo some of the lacing here because now that I'm going to use the external bias circuit that's going to go right here, I have to bring back out my bias windings and did a little rerouting, a little cleanup, but when it all comes back together, it'll look neat again. Okay, what we have left here are the heater wires. We're going to go ahead and move on. We've already done the cathodes. Now we're going to move up to the heaters. This is only 6.3 volts, so I'm going to move to a little smaller diameter wire to go across these tubes to feed the heaters, and then we'll move up to the grids and then finally the plate. Okay, we got our screen grid resistors installed, or those are 100K resistors, 2 watt, and we have our filament wires going across the sockets. I still got to do some straightening out of those, make them look nice and pretty, and clean the bottom of the tube sockets because resin gets in there, rosin gets in there. But anyway, all's coming out okay, and we're pressing forward. I'm going to leave this in here kind of loosey-goosey till I decide exactly how I want to position it with respect to the turret board. But that's fine. It can just stay in there loose like that for now. Again, I always say I tighten things up after I make sure everything works. Anyway, more to come. Okay, we got the adjustable bias doubler circuit complete here. As you can see, it's sitting off to the side all by itself. There's the 25K pot. I have the test leads on the place that the original bias circuit would have landed. One lead to ground, and as you can see, our meter reads, sorry for the light here, negative 33.48. The spec for this is negative 36, but the good thing is, if you watch the meter, I should be able to go underneath and turn the adjust, and you'll see the bias go more negative. I had to turn the lights out to show this to you, but now I'm going to start turning the bias towards the more negative direction. And there it goes. I can get it all the way down to negative 70 or so, negative 90. So on the low end, or more negative end, I have 90, and I can adjust it all the way to where it's runs hotter, all the way up to negative 33, which is perfect range. Now, when this is loaded on the tube, this voltage will change. That's why I wanted a larger range. When I first put the tubes in, I will crank this back down to way negative, probably around there, right about there when I first plug it in. That way the tubes are running close to cutoff or cold, and then gradually bring this bias voltage up till I get the proper cathode current per the test points on the back. But the good news is the circuit works. It took a while to get the right resistors into the circuit to get this right spread, but we're there. Now we're going to move on to installing the output transformer and connecting up the power tubes and the output jacks and the impedance selector. So stay tuned. Okay, we are ready to install our output transformer. This is a reproduction of the original Partridge output transformer. It's as big, if not bigger, than most power transformers on 100 watt amps. Anyway, we have our secondaries, which go to our impedance selector switch and to our output jacks, and our primaries coming in from the power tubes. The nice thing is I can cut these wires and use them across all the tubes. This is coming out okay. There's a couple spots I'm not real happy with. Some solder joints on the turrets because I tend to use oversized wire. But what was nice is I was able to, you see no bias circuitry here. I'm able to bring the bias in from this doubling circuit that's adjustable and just tap it right here instead of having the capacitors and the diodes all right there. So it makes it look a little cleaner. It's going okay. My first time in doing this in 30 years, I cannot complain. If I had to do it again, it'd be twice as neat. But for a test bed, this is just fine, and everything is sound electrically. Anyway, here we go. First thing we have to do is remove our tone wood. This served its purpose, but now it's time for it to go. Got to go ahead and put on the output transformer now. I'm using 4 of these 1/4-20 stainless screws, about 1/2 inch long, to install the transformer. Nice and big and wicked sturdy. First thing we have to do is start feeding our wires through the grommets. Go, peekaboo. Careful not to get them kinked. Our first screw started. Okay, we have our transformer installed. Got plenty of lead length, I hope. Okay, we are done with the HIWATT DR103 power supply and PA section. I turned the overhead light out so you could see a little better, especially see the meter. Cleaned it up. Got a couple little things I want to fix, like that strapping right there is a little too close to ground wire and that sort of thing. But all in all, it's pretty clean. I'm going to go ahead and do a pinout voltage check on this last tube here. That'll let me know that everything is working correctly. Stand by for that. The first thing we're going to test are the filaments, 6.3 volt AC filaments. They come into the tubes from this end, so if they make it all the way over there, I know everything's fine, and at least it should be fine. Anyway, stand by. Okay, we are hooked to the cathode pins. This is AC voltage on the last tube there. Go ahead and turn the power on. Hopefully nothing blows up. Nope. And you can see our voltage is 6.54 volts AC. That one is good. Next, we're going to check the plate voltage. And for that, I believe I'm going to have the standby switch on. Next is our plate voltage check. That's going to be on pin 3. That actually comes from the standby switch through the output transformer center tap and then to the plates of the tubes. I should get around 450 volts for that. So first we turn on our main. We turn on our standby. Standby to standby. Look at our meter and we have 469. Very good. Perfect. Okay, next we're going to check the screen grid. That should be about the same as the plate voltage. Let's see. First we turn on our power. Here we go. And we turn on our standby switch, and there we have 469. That's pretty good. Okay, next we're going to check the control grid, or pin 5. That should be around negative 35 to negative 40 volts. This is adjustable, so as long as we get in that range, I know that's going to be good. So again, I think this just requires the main power switch to be on. So we turn that on. Go down to our meter. Look at that. Negative 35.8 from my adjustable bias circuit. Perfect. Of course, when the tubes are in these voltages are going to change again, because as a tube conducts, as current goes up, voltage goes down. So we can take a look at them again, but this is a good start that the static voltages are where they need to be. So now I can move on to the preamp side and for part 3.